All right, get ready. Today we're going deep into quantum physics, exploring the work of Otto Stern through this fascinating essay by Jürgen Schneeppert.
Otto Stern, yeah, his work is incredible.
He wasn't just some scientist stuck in a lab. His discoveries actually led to technologies we use all the time.
Yeah, things like GPS.
And MRI technology. Seriously.
It's true. He had this amazing ability to take these complex ideas from quantum mechanics and make them into real-world stuff that we use every day.
And it all really started with one groundbreaking experiment, the Stern-Gerlach experiment. Before that, scientists thought of atoms kind of like these tiny magnets that could point in any direction they wanted.
Right, like just randomly oriented.
But Stern and his partner, Walther Gerlach, totally changed that idea.
Yeah, and they did it in a way that seems really simple when you hear about it. Imagine shooting this beam of silver atoms through a magnetic field, a specially designed magnetic field, of course.
Okay, so they're shooting atoms.
Right, so you'd think, logically, that those atoms would just kind of spread out randomly on the other side.
Yeah, that makes sense. Like if you threw a bunch of confetti in the air, it would land all over the place.
Exactly. But that's not what they found. Instead of this random spread, they got two distinct beams.
Two very specific beams.
Well, yeah, which was a total surprise. It meant the atoms weren't spinning freely every which way. They could only spin in specific directions up or down.
Wow, so it's like the atoms are way more organized than anyone ever thought.
Much more organized.
And that wasn't just some cool observation. It completely changed physics. This thing called spin quantization. It's one of the core ideas behind quantum mechanics.
It really is. That's a fundamental principle.
It blows my mind that an experiment that sounds so straightforward could rewrite our understanding of how the universe works. Schneeppert also talks about Stern's work with molecular beam methods. Can you explain what that is? What was he doing with these beams?
Well, imagine you want to really understand how something works, like a tiny little atom or molecule. You need to isolate it almost like you would look at a tiny little thing under a microscope, right?
Okay, so you could really look at them individually.
Yeah, and that's basically what Stern did with his molecular beam methods. He created these beams of particles, like atoms or molecules, that were flying through a vacuum, so they're kind of isolated little labs.
So he's got these super focused streams of atoms. What could he learn from doing that?
Oh, tons of things. Like by watching how these beams interacted with things like magnetic fields or electric fields, Stern could actually measure the properties of these tiny little things.
Okay, so he was finding out what made them tick.
Exactly. Things like their magnetic moments, how much they're attracted to magnets, and how they bounced off of other particles.
He was really getting a close-up view of the building blocks of matter. And he wasn't working alone, was he? The essay mentions he collaborated with some big names like Einstein and Max Born. What made Stern such a great collaborator?
He had this unique ability to not only understand complex theories, but also figure out how to test them with experiments. And that made him the perfect partner for theoretical physicists like Einstein and Born. They could throw ideas around with him, and he'd find a way to actually see if they were true.
Like a bridge between these really big ideas and real-world results. Now, Schneeppert talks about Stern's early life. It sounds like he was destined for greatness. Born in Germany in 1888, it seems like he was always fascinated by science.
Absolutely. And his academic career was pretty amazing, too. He got his doctorate in 1912.
Oh, wow.
And his supervisor was, get this, Albert Einstein.
Wow. Imagine having Einstein as your PhD advisor. No pressure, right? So we've got this incredible scientist, mentored by Einstein, who goes on to do this revolutionary experiment that changed the way we think about the universe. I can't wait to hear more about the impact of his work.
Me too. It's a really fascinating story. And Schneeppert doesn't shy away from the fact that Stern's journey wasn't always easy.
Yeah, I can imagine. There were some pretty turbulent times back then.
Definitely. Especially with the rise of the Nazi regime in Germany, Stern faced some huge challenges. It ultimately forced him to leave the country.
It's heartbreaking when you think about it. These brilliant minds driven out of their homelands because of politics, it really makes you wonder what other amazing discoveries could have been made if things had been different.
You're right about that. But even with those hardships, Stern's love for science never faded. He continued his work when he came to the United States, and eventually his contributions were recognized in a huge way.
Oh yeah, he won a Nobel Prize, right?
He did. In 1943, he received the Nobel Prize in Physics. It's a testament to how groundbreaking his research really was.
Absolutely. A Nobel Prize, groundbreaking experiments, mentorship from Einstein. What a legacy. And here's the thing that I find so incredible about Stern's story. His work wasn't just confined to some lab or a textbook.
You mean how it had real-world impact?
Exactly. His discoveries actually led to technologies that we use every single day.
It's true. That's one of the most amazing things about Stern's work. It wasn't just theoretical, it actually laid the groundwork for so much of the technology we rely on.
Like take GPS, for example. Those super accurate atomic clocks that make GPS possible. They're directly connected to Stern's research on how to manipulate atoms.
It all goes back to his work. Stern helped us understand how atoms interact with magnetic and electric fields, and that understanding is crucial for building atomic clocks that are precise enough for GPS to work.
So next time you're using your phone to find your way around, remember Otto Stern.
I'll try to.
And while we're on the subject of technology that seems like it's straight out of science fiction, remember we were talking about quantum computers?
Yeah, incredible stuff, those qubits.
Well, those qubits, the building blocks of quantum computers, rely on this concept of spin, the very thing that Stern and Gerlach proved with their experiment.
It all connects. Those qubits leverage spin quantization, which is exactly what Stern and Gerlach demonstrated. It shows how impactful Stern's research really was. It's still shaping the future of computing.
It's pretty mind-blowing that research from almost a century ago is still so relevant today.
Yeah.
And there's another area where Stern's work has had a massive impact. Magnetic resonance imaging, or MRI.
Oh yeah, MRI. That's an amazing technology.
It is. This life-saving medical technology that lets doctors see inside the body without surgery, it's actually rooted in Stern's research on how atomic nuclei behave in magnetic fields.
It's a perfect example of how seemingly abstract physics research can lead to such incredible real-world applications.
Absolutely. Stern might not have envisioned MRI specifically, but his work on nuclear magnetic moments was a key step towards its development.
That's so cool.
It just goes to show you how important it is to support basic scientific research. You never know what amazing innovations might come from these theoretical explorations.
I totally agree. So after this deep dive into Schneppat's essay on Otto Stern, what are your big takeaways?
Well, for me, it's Stern's incredible ability to come up with these elegant, clever experiments that revealed fundamental truths about the universe.
I agree. His experimental skills were truly remarkable.
And it's not just about the brilliance of his experiments, but the lasting impact they've had. His work has shaped the world we live in and continues to inspire new discoveries.
Absolutely. It's an inspiring story, not just for scientists, but for anyone who's ever been curious about the universe. Stern's journey shows us that curiosity, perseverance, and challenging conventional wisdom can lead to truly remarkable breakthroughs.
Makes you wonder what other scientific mysteries are out there just waiting to be solved.
Oh, definitely. Especially in quantum physics, there's still so much we don't understand.
It's true. We've learned a lot, but there's always more to discover.
And thanks to people like Otto Stern, we're making progress, uncovering the secrets of the quantum world.
Definitely. And this deep dive, based on Jürgen Schneppat's work, this essay, has just scratched the surface. I'd encourage everyone to check out Schneppat's writing to really get into Stern's life and research.
Yes. It's an inspiring story, not just for scientists, but for anyone who's ever been fascinated by the universe. Stern's life really shows how powerful curiosity, perseverance, and challenging the status quo can be when it comes to making new discoveries.
Exactly. So, what's the main takeaway from this whole discussion? Otto Stern's work, especially that groundbreaking Stern-Gerlach experiment, wasn't just some abstract scientific theory. It actually laid the foundation for technologies that we use every single day. It still shapes the development of cutting-edge fields like quantum computing.
Yeah, I completely agree. And it kind of leaves us with this thought-provoking question. What if Stern hadn't had to flee Germany? How much further along would quantum technology be today? It's a question that really makes you think, doesn't it?
Definitely food for thought. I guess that's the beauty of these deep dives. They make you ask more questions and keep exploring and keep learning.
Absolutely.
So until next time, keep on diving.